All right, you guys, here we go on the fly. Everybody write direct variation, okay? So as you can see on the board on the right here, we have, I'm sorry, not direct variation, scatter plots. I'm sorry, scatter plots. Okay, this is going to be the Fast and the Furious. It's super fast. We actually touched on this like before for like our semester exam. But anyway, in this video, it's going to be a combination of scatter plots and direct variation. So this is basically the gist of scatter plots. Scatter plots have a bunch of dots all over them, and they're kind of, if it has a positive correlation, okay, just like a positive slope, all the dots that are grouped together are you know, it's like a trend. It's generally going in the positive direction, and that's called a positive correlation. So the question might say, what kind of correlation does this graph have? Well, you can see that all the little dots, you know, are going in up in a basically a positive direction. So that would be a positive correlation. And then this red line here is called the line of best fit. So what you need to know is that the line of best fit is like the average, right? It goes straight down the middle of all of those, you know, dots, okay, which basically represents the average of that trend, of what is trending, okay? And then same here with the negative correlation. All the little dots are going in the negative, right? And so it's the trend, it is going in the downward direction. So that would be a negative correlation. Okay. And then this is the line of best fit, which also represents the average of that downward trend. Okay. And then you have like what I call chaos. Okay. This is just all over the place. It has no pattern, no rhyme or reason. Okay, it's just all over the place, and it has, which means no correlation at all whatsoever, and you wouldn't be able to make any sense out of it at all whatsoever. Okay, so what you're gonna, those are the kind of questions you're going to be asked about you know, scatter plots. So they'll either say, is it a positive or negative correlation, or what type of correlation is it? And, you know, what would be the line of best fit? So maybe there would be like, you know, a line here, or, you know, there could be like a line, you know, here underneath it, right? And it would say, you know, which line is the line of best fit? Well, you'd actually choose, you know, the one that's right smack in the middle of that trend, okay? Because that represents the line of best fit that represents what is trending, okay? And then super fast, here's an example of what you would get, right? So it's just about wages, meaning what? How much you earn, right? And so you just have to, you know, here's the money, the wages going up this way, and then, you know, how many hours you worked, okay? And so obviously it says, here's the kind of question you'll get. Determine whether the graph shows a positive, negative, or no correlation. So as you can see, it's generally going up in the positive direction. So that would be a positive correlation, right? And then describe its meaning in the situation. So basically we have, you know, your money, wages, and hours. So as you can, so you would just write one or two sentences explaining what you see in this graph, which would be that, you know, obviously the more hours you make, the more money, I'm sorry, the more hours you work, the more money you're going to make. Okay, so that's it. That's our lesson on scatter plots. So everyone draw a line under that and title the next section part 2, direct variation. Okay. Okay, so direct variation, let's take it one piece at a time here. Okay, direct variation is going to, where's the thing here? Okay. Okay, so here's our title, direct variation. Cam, am I still, is this still okay, like in the screen? Okay, so here we go. direct variation is going to be very similar to our slope-intercept form. The direct variation formula is y, okay, this is running out of ink, hold on. Okay, you're going to write y equals kx, okay? And this is one of those things that we're just going to have to get to know the way that the question is going to be asked of you is, and it's going to sound weird, but you know, at least I'm telling you what it's going to sound like so that when you see it and read it, you'll know exactly what it's saying. It's going to say, suppose y varies directly with x. Is this a direct variation? I want everyone to go ahead and circle the K, circle it now, draw a line, and I want you to write that this is the constant, okay, the constant in that formula, okay? So hopefully, you know, we just finished Unit 3 where we were talking about the equation of a line in slope-intercept form, okay? Y equals mx plus b. This looks kind of similar to it if we were to, what? If we were to erase that plus b part, right? And change the m to the k, we would have our direct variation formula. What I need you to know, okay, is that when you have, it is like the K, the constant, does represent the slope, okay? So that is the formula. That is how you have to recognize it. Y equals kx, and the K is the constant. And in order for something to be a direct variation, this K needs to be the same number every time. And I'm going to explain that to you in a moment. So let me just make sure you just write down that version of just write down the formula. So let's take a look at the graph, what the graph of a direct variation would look like. So go ahead and draw this in your notes. Doesn't have to be perfect, okay? But what you need to know is that the graph of a direct variation will always go through 0, 0. A graph of a direct variation will always go through the origin of the graph, okay? And that kind of makes sense because if I write that formula again that we just wrote down, right? We just wrote y equals kx. Well, this is where it stops. There's no plus b, like y equals mx plus b. There's no plus b, okay? So if there's nothing there, what did we say before? If there's nothing here, if it's like plus 0, if there's nothing there, then that's your clue, that is your hint that the line crosses over the y-axis at 0, 0, okay? So that's what the graph of a direct variation looks like, okay? So let's move on. So that's your clue, the way that you can notice it on a graph. Now we're going to talk about identifying a direct variation by looking at it, okay, here as an equation. So I'm going to make this super easy, okay, just like I did when I was teaching, you know, like terms. If it doesn't look exactly the same, then it's not like terms. Well, let's write y equals kx again. This is our direct variation, right? So I'm going to say the same thing to you, how we identify a direct variation. If it doesn't look exactly like this, y equals kx, if it doesn't look exactly like this, after you've solved for y, then it is not a direct variation. It really is that simple. So here we have 7y equals 2x. Okay, and you have to solve for y, so everybody write step 1. Well, there's really only one step. That's it. The only step to be able to tell if it's a direct variation or not is to just solve for y. That's all you have to do. Are you writing this down, Josh? Okay. So all you have to do here is solve for y. What's our only step, Tommy, to solve for y here? Is what? What? Okay. How do we get the y all by itself? Divide by 7 on both sides. Y equals 2/7 x. Okay, so, and I don't know if you can really, I'm going to write it down here because I don't know if you can really see it that well with the blue in the video. So we divided by 7 on both sides, bring down your y, and y equal, oops, I put 3. Why did I put 3? Hello, people. Y equals 2/7 x. Here it is. Now, does this look like our formula y equals kx for our direct variation? Yes. Therefore, check. Yes, this is a direct variation. Yes, it is that easy. Okay, so let's try the next one. The only step we have to do is solve for y. So here we go. Circle the y. Okay, so we're going to subtract 4x from both sides. We have 3y equals negative 4x plus 8. Divide by 3. Divide by 3. Divide by 3. Those cancel. Y equals negative 4/3 x plus 8/3. Circle your answer. Is this a direct variation? Yes. Because I subtracted 4x from both sides. That's our first step, okay? So, good question. So, guys, here's our result. The only step we have to do is solve for y. We solved for y. Is this a direct variation? Does this look exactly like our formula for direct variation, y equals kx? No. Why is this not a direct variation? Because we have plus 8/3 here. So, no, this is not a direct variation. Remember, the graph of a direct variation goes through the origin 0, 0. So if anything, it should just say plus 0, okay? It should not have anything for a y-intercept because all direct variations go through 0, 0, okay? So it cannot have plus or minus anything. It has to look exactly like this. Y equals kx. Okay? All right, so that's how you identify a direct variation from any equation that they give you. The only step there is to what? Solve for y. Moving on. So here's a typical question that we're going to have to get used to, okay? So we're going to write this title, Writing a Direct Variation Equation. And I'm only going to do one example for this video, but we're going to do the second example live together. But just for the video purposes, we're just going to do one example together, and then we'll do the other practice example together off the video. So here we go. Here's that phrase again that we have to get used to, guys. It says, suppose y varies directly with x. Okay? That is your clue. That is your hint. That is your ding, 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 that this is, varies directly with. Okay? That means it's a direct variation. Okay? And automatically you should say to yourself in your mind, y equals kx. This is what should automatically, right off the gate, okay, should come to mind, y equals kx. When you see suppose y varies directly with x. Yes. Okay, now, it tells you what y is equal to. Y is equal to what? 35. Okay, and x is equal to what? 5. What direct variation equation relates x and y? Well, let's bring it down. Y equals kx. And what do we always do after we write the formula? We rewrite it with the empties. So we're going to empty equals k empty. So y is 35. Let me use a different color. So we're just going to substitute, you guys. 35, and then our x is 5. Okay? And we're going to solve for k. Easy peasy. Divide by 5 on both sides. Those cancel. And k equals 7. So now that we know what our constant is, right? The k represents the constant. Now that we know what our constant is, then part 2 of the question says, what is the value of y when x equals 9? Well, we first have to write our direct variation equation now. Now that we know what k is equal to, now we can write our direct variation equation. So using the value of 7 for k, if we're writing y equals kx, and we know what k is equal to now, which is 7, our direct variation equation is going to be y equals 7x. This is our direct variation equation because we solved for k. We found out based on what they gave us, y was equal to 35 and x was equal to 5. We solved for k, and we got 7, okay? So now we put our 7 in for k, okay? This is our direct variation equation. And now the question says, what is the value of y when x is equal to 9? Well, once again, it's just substitution because y is equal to whatever the result of this is. So we're going to rewrite it with the empty, and we're going to substitute the value of x that they gave us. They said x is equal to 9. So we're going to put 9 in here, guys, do the math, and then y equals 63. Done. This is a typical question on the algebra EOC. Typical, typical, typical. So what was step 1? Step 1 was to solve for the constant, okay? That was step 1. Step 2, now that we know what k is equal to, write the direct variation equation and plug in the value of x and solve for y. Okay, so that's one example for your notes. We'll do a practice example after I finish recording this video. But I think this is going to be part 3 now. Okay, so we're going to be able to tell a direct variation. Marvin, can you get a calculator real quick? Because we're going to need calculators for this. Okay. So thanks, hon. Okay, so part 3. Writing a direct variation from a table, okay? Part 3. I'm going to do this example with you in the video, and then we'll do these 2 examples together live, okay, for some more practice examples. But this is the only example that we need for our notes. And once again, when you see direct variation, you guys should be writing y equals kx. Woo! This is what should come to mind. Okay, y equals kx. All right, so what you're going to do, okay, is everybody circle this k again, this constant. Put the star, draw the arrow, and write the word same with an exclamation mark, smiley face, and under squiggly, okay? Listen, guys, in order for any of these tables to be a direct variation, okay, the k, the constant, has to be the same every single time, okay? But how do we know if the constant is the same every single time in a table here? How do we know if the constant is the same every time here? How do we know if the constant is the same every time here? This is how you do it with a table, okay? So what you need to do is you need to know what k is. You have to solve for k. How easy is this, you guys? Watch. You have y equals kx. So if we want to know what the k is, we got to get the k all by itself. How do we solve for k? By dividing by x, and we have k equals y divided by x. Whoops, excuse me. Okay, y divided by x. That's all you have to do. right? So now that we know that the constant is taking the y value in the table and dividing it by the x value in the table, and if you get the same number every single time, you know you have a direct variation, okay? So let me show you how this works. So Marvin, let's do this, okay? So here's our x values, here's our y values, right? So for each one of these, you're going to take the y and divide it by the x, right? Y divided by x, right? So what is 6 divided by 4 give us, Marvin? 0.5? Okay, 1.5, okay? Now do it again. 12 divided by 8, what does that give us? 1.5. Do it again. 15 divided by 10 gives us what? 1.5. Guys, do you see that it's the same every time? We took the y value divided by the x value, y divided by x in the table, and we got the same every time. Guess what? Check. Yes! Exclamation mark. Yes! That is a direct variation. That is how you tell from a table if you're looking at a direct variation. And we're going to do these two examples together live off the video. Okay?